Our next speaker has nearly 30 years of field-based research experience based in northeastern temperate ecosystems, and has a passionate interest in the complex relationships between public and private land management and the crossroads between science and policy. This includes GIS spatial analysis work, which, when I hear that, that's enough. I'm already like, okay, you win. That's excellent. Please welcome Dr. Stacy McNulty.
Thank you, Bridget, and thank you all. I'm really honored to be invited to this conference today. I'm happy to come. It was a beautiful drive here this morning. Okay, so I was asked to talk about climate and wildlife and what we've learned in a slightly different part of northern New York State. I'll show you where I am in a minute, but we're going to go over some information about what is the Adirondack Ecological Center. We have a mission that reflects what the State University of New York College of Environmental Sciences mission is at large, except that ours is place-based in the Adirondack Park. So that's what my neighborhood looks like this morning and often there. And I'm just curious, raise your hand if you've been to the Newcomb Central Adirondack area. I'm guessing some of you have. Oh, lots of you. Wonderful. Well, if you haven't been there, I hope you will maybe consider coming up after I speak. So our mission is really about doing research and then translating it to various communities, our neighbors, the people that visit the Adirondack region from all over the world, our colleagues across the world in science and education and other places, but we really enjoy the part where we get to share our science and our excitement about our science. So just what I'm going to talk about today is a little bit of background about some of the research that we've done at a large field station that ESF operates in the central Adirondacks. And I'm going to pick on some species. I can't talk about all of them, obviously, but some that I think will hopefully resonate with you all, that are things that you probably have experience with. And Dr. Twist's talk actually is wonderful, some bit of background for a little bit of what I'm going to talk about. And then maybe a tiny bit about what we hope to be doing in terms of that research and that translation into the next century. So the Huntington Wildlife Forest is the physical space. It's a field station that's about the size of the island of Manhattan. It's a very large research area that ESF is fortunate to have had since 1932. So we've been there for the better part of 100 years doing research on the lakes, the watersheds, this part of the upper Hudson River. And so we have miles of streams, lots of places to do work up in the headwater region. So we're in the Hudson. We have about 1,100 acres of old growth forest, which also enables us to do comparative studies. What's happening in a forest that has been unmanaged and really left alone for a very long time? How does that differ from one that might be experimentally being managed by people? We have, fortunately, we have a year-round staff, and so scientists really like to come there because we can, unlike a public area, we can put equipment out, we can dig soil pits and not worry about people falling into them. We can do things to that landscape and also leave it alone and kind of watch it. So there's experimental and sort of reserve areas to this space. And one thing that I want to highlight now, as you think about the things that I'm going to speak about, mind the fact that where we are in this part of northern New York, there's very little roads, very little industry, very little development. So the things that we are seeing in the environment really have largely to do with either very small scale things that are happening within a lake or within a watershed, or very large scale things like climate and weather patterns that are coming from a much larger region. So it really is an opportunity for us to say, are we somewhat of a canary in a coal mine when it comes to things like climate change? Just to give you a sense, if you've not been to this region, obviously it's a little different than the St. Lawrence. It's the headwaters of the Hudson River, so the lakes have anywhere from 500 to 1,000 acres in size. These are some of the lakes where people do a lot of their aquatic research, and so some of them, as I said, are surrounded by areas that either have a very old, 350-year-old forest that's been a really nice kind of opportunity for us to talk about what's happening in a system that is not being managed, and then places that have had a fire history, for example, because large parts of northern New York had a very extensive fire history about early 1900s. So we can compare what's going on in some of these places. Wolf Lake, in particular, in the upper right, that lake actually has never had any non-native fish in it, luckily for us, because of the positioning on the landscape and the ownership patterns in the past. That lake has largely pretty much been just doing its own thing for a long time. So I would not say it's not changing. We actually are seeing changes in that watershed, but what's happening there is not because of introductions of bait fish and other things. The lower left, Rich Lake, that's one that if you've been to that area, you might have come to the Antarctic Interpretive Center or come and paddle or fish there. That is one part of the campus that is open to the public. The vast majority of the campus is not. And then the Arbutus Lake, that one, if you've ever seen any watershed data, we do a lot of air, water, stream pollution collection, and that one is where a lot of the chemistry data is coming from. So if we know something about this part of the region, that's probably where that data is from. We also do a lot of educational programs for K-12 and college and public audiences, and so we're able to take people out onto the waters and really get them to experience it, sometimes for the first time. And it's really joyful to be with students who have never canoed or kayaked before or been swimming in a river that, you know, doesn't have concrete around it. So it's a really fantastic laboratory for us to be doing our science and to be sharing that science with various audiences. We do a lot of work there. Sometimes we're doing things up in the uplands. I'll talk a little bit about that. And then a lot of time we're working in the aquatic system. So, you know, we're trying to figure out what's going on from the very base of the food chain and looking at the plankton, what's happening in our lakes, and then looking at, you know, sort of the more top predators. As you can imagine, a research station is probably going to be collecting a lot of data, which we do. And so here's a list of things that we want to try to measure. So it's anything from temperature, pH, what species are living there, how are those organisms interacting with each other, from sort of predator-prey relationships, looking at the various niches ecologically that they might be occupying, and then looking at change. What's going on with carbon storage, carbon mobilization across the landscape? What's happening? Are we seeing systems recover from some of the damage that was done in the 20th century? And if we are, why is that happening? And how can we compare what we're seeing in our area to places that might still have more of an impact of things like agriculture, development along shorelines, and so forth? Recreation is another one that we often are comparing to. And we're really trying to take that science from the field and really get it into policy. And I'm happy to say a lot of the people here who are my past and current colleagues, the work that they are doing in the field to collect that data is going into congressional hearings, is going into policy at state and national levels. And so we're fortunate that ESF has been running this place for a long time and providing information on this part of the landscape to tell us what's going on and are we happy with what's happening from a societal standpoint. If not, maybe there's some policy change that we might need to affect. So a couple of the ways that we're doing that data collection, if you've heard of the National Atmospheric Deposition Program, that was associated with the acid rain problem in the mid-20th century. And one of the first places and most important places that have collected that data, this is one of the original sites that was collecting since the late 1970s. So we have 50 years of data on what's happening with soil and water, pH and pollution. How has that changed through time? I'll show you a little bit of that. Another thing that was installed about 10 years ago, SUNY Albany has a statewide, what we call a mesonet. So this is atmospheric data. You all have them here in this county. Every county has at least one of these stations located somewhere. The one in our area is where I am in Essex County. And that's co-located because we already had weather data that went back to the 1940s. We knew a lot about the place. We had a really good record. And so for the state to put in something, this mesonet was actually an emergency response that happened after Hurricane Sandy and a couple of really damaging storms hit other parts of New York State. The Adirondacks was damaged by some of those hurricanes that have been kind of hitting with increasing frequency. And so in order to give the emergency responders better data, the state decided to invest in this system. And what I would recommend to you, if you haven't ever looked at the New York mesonet, I would encourage you to do so because it is actually the best forecast that I personally can access from where I am. Way better than getting a regional forecast that comes from sometimes hours away. And as you know, if you're in the mountains and in these places with terrain and a lot of factors, you have big bodies of water, the weather forecast may or may not be accurate for where you actually are, but mesonet is pretty good. But we're using it in our case for predicting and looking at both current and predicting scientific connections between what the weather is today, yesterday, the past year, and then potentially using that to understand what might be happening in the system. And the last thing on this slide has to do with our weather station, which is that bottom picture there. There's a lot of data being collected. A lot of the things that our ESF is doing are publicly funded, either through NYSERDA or federal funding. There's a variety of different projects that are going on. Some of them are long-term and others are shorter duration. And all that biogeochemistry data that's happening in this space, as much as we can possibly put out there, is on that website. That's at adk-ltn.org. So you can go and look at what's actually happening. And there are cameras and all sorts of things. And if you're a science person or a teacher that is excited about sharing real science with your students, or if you just want to explore it, you're welcome to come and take a look at that anytime. We are trying to push out as much of our data to the population that's interested as possible. So let's get into a little bit of what we know about the place. That's all the background stuff of how we're collecting some data on the place. But what's happening in our part of northern New York? Well, climate weirding is what's happening, right? We're seeing a lot of variability. And so for us to be able to look at decades is really important, because we can say, this is what's happening today, this week, right now, this season. How does that compare to past years or past decades? And so when I look at things like summer temperatures, there's a very mild trending northward, trending in warmer temperatures. We've gained a couple of degrees. That's consistent with a lot of northern climates. We're seeing temperatures rising, both average and sort of baseline temperatures, the minimum temps. So we're seeing that in the summer and the winter, but it's still really messy. We have a climate that's affected by a lot of things, right? And the terrain, the topography is affecting that. We're not really looking at the averages in this case. I think it's worth it to look at things like some of the extreme events. And I think this will resonate with many of you here. These extreme events that are happening that are either more extreme precipitation is usually the thing that we're paying the most attention to, but also things like heat. We had several days well above 90 degrees Fahrenheit last summer. That's really unusual for where we are in the mountains. So when we see things like this, 2 years ago, we had a really severe flood in the central Adirondacks that was due to a couple of factors. That bottom graph there, the red line is showing kind of average precipitation through that part of summertime. So usually we might get 12 or 13 inches of rain total. It tends to be a wet climate in general. But in 2023, we had a couple things happen. When July 4th hit, it had been kind of normal, and then we had a lot of rain. That's where you start to see it tipping up there. Suddenly, around July 10th and 11th, we had about a 36-hour window where we had an extreme precipitation event, and it dropped 8 inches of rain on this one area. So if you've been to the Newcomb, Long Lake, Blue Mountain area of Hamilton and Essex County, right in the center of the park, that area got so much rain, the ground was already saturated. And unfortunately, what usually is a pretty, we can saturate that landscape with a lot of water without too much damage where we are. We're in the upper part of the watershed, not the base. It was too much for the system, and some dams and things gave way above us, and we had some really severe damage to our campus and to our neighborhoods and our neighbors. So it broke highways, it did a lot of damage. That's my colleague who's standing about 8 or 9 feet deep in a chasm that was a road. So this is something, I don't think this will surprise any of you. I know there's been a tremendous amount of flooding in any of our places. We have a lot of water in northern New York. We're so fortunate. But this is the downside of that climate effect, as you know. So this was one of our boardwalks from our interpretive center trail system that washed away all the water in the Hudson. And this was just one single event. It caused millions and millions of dollars of damage to our campus. Fortunately, New York State has been reinvesting. We've been able to repair a lot of that damage. But we're really concerned about the fact that this is going to happen more frequently to more and more of our communities. And it's been hitting Vermont. It's been hitting different parts of the Northeast, as you all know. If we switch to winter, as you heard earlier, we too are seeing real impacts. And obviously, the lakes where I am are much smaller, but there's still a really profound impact on the system. So this data, I actually am only showing you part of it. If I go really all the way back to when we start having records of people talking about writing a letter to their boss to talk about how they snowshoed across the lake at Thanksgiving, that is not something you would probably do these days, right? So I'm just showing you a portion of it that's more, maybe since 40 or 50 years ago, because the trend is for sure happening. We've lost about almost a month of winter at this point, if we're measuring it by things like actual lake ice cover on those lakes. This is a really easy thing for us to measure because it's really obvious when the lake turns to ice, right? And what's happening is we're seeing it's because the fall is much warmer. We're having a heated earth, and it's if things are cold, it's not staying, right? The ice is not really sticking around, so it'll kind of freeze and thaw and freeze and thaw. So although we have interannual variability, as you can see in that graph, on the whole, that trend is going to less ice duration. Now, We're starting to get down where we're having years where we might only have 3 months of ice cover, or 3.5. That's a really big difference from decades ago, as you can certainly imagine. So this late ice in, spring is actually coming about the same time in April most years, within about a week or so, but we're really seeing a massive difference in the beginning of the winter season, if we were calling it that. So it might still be snowing, but what's happening in that ice and under that ice is going to be dramatically different as this continues to happen. So some of the impacts, I think this will mirror what you heard earlier, right? We're kind of fuzzy on what's going to happen, but we know that there's impacts of things like oxygen, the level of oxygen in the lake, because the ice is going to trap gases, right? And there's going to be different exchange if the water's open and still churning versus if it's not. That will impact the species that are living in the water, as well as the ones who are utilizing that. So a lot of predators, right? We have otters and other species that are accessing that space to go feed and move around. We have a lot of concerns about our fish communities because many of them are cold water, as you well know. So that brook trout, that beautiful fish in that picture, I put that in there fuzzy for a reason. We're concerned about that heat coming into the lake, right? Because ice and snow will bounce the solar radiation back out to the sky, but an open water body will continue to absorb heat. So what happens to when the lake stratifies? What happens to turnover? What happens to all of these things in terms of when are the plants getting light? Are they growing or not? What's going on in terms of potential introduction of invasive species into those lakes? And the more of this that happens, the more likely that is that we're going to continue to see introductions of new things that are more able to deal with these new sets of conditions that we're seeing. And I won't mention anything you already heard about the cultural piece. This is important to our way of life here. We are people of winter to some degree if we live in this environment year round. And so I'll just point out that paper by colleagues in the upper Midwest talks a lot about the cultural loss of ice from lakes and rivers in the Great Lakes and our northern ecosystems. It's a great paper to talk about what people are thinking about on the social side of this research. When it comes to snow, if we switch up to just looking at snowfall, we're actually seeing more precipitation, but it's more falling as rain. So again, it's bouncy. I've tried to kind of average it out, the little red dashed line through this very bouncy graph. We have years where we have lots of snow cover and years where we have less so. And as we go back in time, we can go back to the early 20th century and continue this data set. We obviously used to have more snow for longer and deeper snow. That matters too, right? The kind of snow that we get matters, not just whether it's there. So the graph on the side, that little table, we're seeing a lot more wet snow, and I'm sure this is true of all of your experience as well. We used to have, it's something like 10 inches of snow equals 1 inch of rain. So 80 inches of snow is really different than 100 inches, but when we're talking about actually adding rain to that system, we're seeing a big difference in the snowpack quality because it's less insulating. And it can be icier, right? And so now you have an issue, you have lots of issues if you have ice rather than snow in terms of human safety, human enjoyment of being outside. And what we're seeing is the last 10 years or so, almost all of them, we continue to see this ticking upward of more moisture, more coming out of the atmosphere and dropping. And sometimes it's snow, like this year we've had a lot of snow in our region. But a lot of times we're now getting these, what we call rain on snow events. And so that's really messing with the insulation for plants and animals and all the creatures that are living under there. Because this is a system that has evolved to be pretty stable from a thermal standpoint in the winter. And so you have a pretty warm ground cover layer. The animals that are living down there that are actually active, there are a lot of animals and plants and things that are still active during the winter, they're not covered anymore if there's not that snow cover. And the snow cover really needs to be at least 8 or 10 inches deep to really be doing any kind of insulating, and 15 inches would be a lot better. As soon as you get that much snowpack, whatever's happening up above, it doesn't matter if it's 20 below. Down below, it's about 30 Fahrenheit. It's pretty warm, actually. So a lot of things are pretty comfortable. And the type of snow matters. We have grouse, for example. Our ruffed grouse, that's pretty common in northern New York, they snow roost. If you've ever been scared out of your wits because something blew out of the snow in front of you, which I certainly have, it's because grouse actually will dive into snowpack when it's fluffy and hang out under there. They'll make a little kind of a roost in the snow at night. It's very warm and they're protected, and they will come out again, after the snowstorm or after it's not so cold. So we have this problem of lots of animals now having to kind of adapt to different conditions than maybe they're used to. So if you're a hunter, you're not able to get through that ice layer that formed because you had rain coming down and freezing into the snowpack. So it's not that we never had ice here, it's that this event is happening more and more frequently, and it's changing our condition of winter, both on a short-term basis and a long-term basis. Lastly, if we're getting rain, obviously that can be a problem. If you're a hibernating animal and you're down in a burrow, you're probably pretty safe from all the cold temperatures, but you're not safe if water gets into your burrow, and you're hibernating and you're not active. So there are lots of problems depending on different species' lifestyles. Plant roots freezing, that's another one, right? There are lots of things that are going to be an issue if we lose that subnivean layer. To kind of get into this, we've had a project going for about 5 years now called the Adirondack Inventory and Monitoring Project. It's trail cameras put out with snow stakes, and this is a winter project. We're trying to really focus on winter with this. So we're working with teachers and just interested people that might have land that they're excited about measuring. You can see that martin is walking, it's got a little pattern there of walking through the snow. We've got a snow stake, we can tell what the snow depth is. We're really trying to understand not so much which animals live here, because we have a good idea of what lives in northern New York, but we want to know how is this differing snow condition across the landscape in space and time affecting the animals' movements and behaviors. And we have a little trouble with bears. Before the bears go into dens, they like to pull down our stakes, so that's what you're seeing there. But what you get is things like fisher and moose and deer and hares and all sorts of things that are big enough to trigger a camera. And after a while, we can start to hopefully get a picture of the whole region and say, you know, what's going on where I am in the central Adirondacks is happening because of this. Perhaps what's happening in the foothills might be a little different, and it may depend on temperature, snow, and other things. So if you're interested in that, come see me. I'd be happy to talk to you about it because it's one that we're doing across the whole region. If we go back to our chemistry data, that NADP project, that started in a few spots, and we're lucky to say that, you know, this has been a success story for our climate policy across the country. You can see between 1985, things were much more acidic than they are today, and that graph's from 2024, that image on the right. But we've had a massive impact of the national policy that has changed things here in the northern country, right? At the same time, we're measuring things like mercury, and we're not really seeing a lot of change there. Partly because there is no mercury standard. There have been no regulations put in at a state or local level, although that's been tried, and we keep having that conversation about mercury. But if you look at the mercury data, we're kind of bouncing around a little, but at least from our data for about 25 years or so, we're not really seeing any trends that would suggest that we're in better shape than we were a quarter century ago. So that's just something to consider. It's not really a climate problem, but it may be exacerbated by things like changes in water, right? If we get a lot of rain events, how does that actually mobilize mercury through a system? What's happening when the water levels go up and down? That's going to potentially mobilize mercury. So if we switch to some of our other creatures, we've been doing a lot of work for the past 40 years monitoring loons in the Adirondacks. We partnered with the Adirondack Center for Loon Conservation. So we're working on the field station where there are no shoreline developments and jet skis and things like that. And then we can kind of compare what's happening in those spaces without a lot of human interaction with animals to, you know, what's the behavior of the birds, how are they doing, how's our nesting doing locally and regionally. And while the adults are doing okay, what we're finding is the nests are problematic. We're really not seeing a lot of chick success. It used to be because, at least from our data, a long time ago, we were seeing that was because of predators. Pretty normal, eagles, raccoons, right? There's a lot of things that will eat a loon egg. Loons can nest over and over again. You know, they can try twice in the summer, and they have a long lifespan. An adult can live 20 years. But if we continue to see this problem, we're not going to see recruitment into the population of new young birds. And so now what we are seeing, and it's even worse now, water level is impacting these birds. The flooding is coming up and flooding the nest. You see how close they nest to shores. Or occasionally, like last year, we had a drought year, and so if the water drops too far, the adults might abandon. So that is, again, natural to a point that would be happening over time. But how much worse is it when we have a 2-inch rainstorm and the water levels come up and those birds cannot save that nest because it gets flooded? So this is going to potentially be a problem. The loons are doing okay right now, and our chemistry of our lakes is better than it was, but we are concerned about the precipitation and this mediation problem of not being able to get chicks to actually live long enough to recruit into the population in New York and elsewhere. And that's an international problem, obviously. We're also seeing a lot of rescues. Last year alone, there were 9 loon rescues in our area, and that is, again, that happens sometimes. Loons get confused and they land on a road because they think it's a water body or something. But we're wondering about a couple things. One, are the birds struggling to find food? Are they having other problems and they're sticking around too long and they're getting themselves into trouble in the fall when we start to see ice in? Or is it possible that climate change is messing with the ice phenology, the timing of that event, and instead of triggering the birds to know like, it's time to go, you need to go south to the coast? A lot of times the juveniles are waiting. The juveniles actually stay as long as possible. The adults will go to the coast, but the juveniles will stay in their natal lake where they were born. And oftentimes they're the ones that are getting iced in. They get into trouble because they don't really know what to expect. And so the more variable the system is, the harder it is for these animals to adjust and know what to do. If we switch to beavers, this is another one I think a lot of you will probably have a lot of experience with. We call them ecosystem engineers because they affect everything, right? They're really impacting the watersheds because they can change water flow, chemistry, the nutrients, depending on where they put dams and other structures. They can affect fish habitat. They're affecting habitat actually in the uplands. We did some research where we found that songbirds actually are more diverse in places with beaver meadows and beaver habitat. And it isn't really the wetland birds, it's the tree canopy nesters. So there's something going on where they're actually making things more diverse and making more places for more species to live. But they're affecting a lot both in the water itself and above it, up on uplands, because they're going up and cutting, you know, they're preferentially cutting trees and making structures like dams and lodges, right? So if you see these things, they're having impact on the system. These are good things, right? Out west, they're actually using what they call beaver dam analogs. They're building things that beavers would have built if they were still there. A lot of places beavers have been wiped out in the west. They were almost wiped out in New York, and they're doing pretty well now, but what we've been looking at is, okay, we have a place where there's no trapping, no hunting, and really nothing is affecting them other than what's happening in the ecosystem, predation and maybe some other things. So if we look at a colony that has a couple of adults and the babies from the last year or two, where are they living? How are they moving around over time? And what does that mean for our ecological system? So maybe they're living here this year, but they were downstream last year and they've built some different dams, and there's all sorts of structure, and that affects the plant communities, it affects everything. So if we are looking at where these families are living, these colonies, what we are finding is that on average, a given site, a pond or a stream site, beavers are there less than half the time over the time that we looked at this. And that is because they kind of eat the food that's in that immediate area, and then they have to move on and kind of relocate. So they need to move around the landscape. So the families will change where they live over time. So that's normal. But we are seeing the colony numbers decline, and we are really not sure why. So this is one of those places where our science, we're watching things long term, but we don't really understand what's going on yet. There could be a lot of things happening here. And we thought, well, there's more precipitation in some years. Maybe that's what it is. When there's a lot of water, maybe they can expand out and have more colonies. But that graph shows, nope, that was not right, actually. So we're still trying to figure out what is happening in our system. There could be a lag happening of time where something happened here and maybe like a year or two later there's an effect. We don't think that it's because of increased predation or disease because we're not seeing dead animals, and we survey pretty heavily for these animals in the fall. We cover that entire 15,000 acres of water. But something's going on here that is causing them to be less numerous than they were a couple of decades ago. And that has implications for water storage, and it has implications for soil and erosion and all sorts of things. So we are going to keep working on this and try to figure it out. And in the meantime, we want to know, because if we can figure out what's going on ecologically, then hopefully that information can translate into some management actions. And rather than trying to, wipe out beavers, which is what happens in some places where they're flooding and causing damage, are there ways to put in structures to kind of, work with them and allow them to be on the landscape more successfully without damaging, human infrastructure, for example. But we certainly know that they have a massive impact on those aquatic systems, and we are going to keep looking at this and try to figure out why we're seeing our numbers decline without any other obvious reasoning. So to kind of come back to the climate change and what's happening into the future, we're going to continue to we do a lot of monitoring. What's happening? How is it changing? What's the system doing? Can we understand things when new diseases or pathogens come in? So when we don't have snow cover, for example, there's a lot of mold and particles and fungi, spores still in the air. And so that leaf litter, when it's not covered, a lot of us get sinus infections and things more easily, and we're getting allergies in the winter because there's not snow kind of covering that stuff up. That is a very sort of human, non-altruistic thing to know, but that is another kind of weird thing that happens with climate change. What is happening with algal blooms? We have actually been experiencing a few harmful algal blooms on small scale where we are, and we are nowhere near inputs from phosphorus, yards, other activities that you would normally think would be affecting some of those things. So when we look at all of these kinds of problems, how are we managing into this? Replacing culverts, right? This is a map of the college's property where we had all that flooding damage. Dozens and dozens of culverts and things were blown out and damaged. We had a ton of work to do. So knowing that this is something we as a research station are trying to use that as an experimental space to learn from. So we brought our landscape architects up after the flood, and we had them come look at the damage and say, okay, your job in the future is going to be doing landscape planning. How can you use this as an experimental place to understand the kinds of changes that you might have to adapt to in your own careers? So it isn't just the biologists running around. Sometimes we're often working with other people that are looking at their training too. So in the face of all of this, we could kind of look confused like this deer after our big flood knocked out our biggest bridge, and we could sort of scratch our head and wonder what to do. But from our standpoint, the Adirondack ecological staff, our biologists, our educators, our foresters, and our others, we will continue to try to share as much of our data as we can. We're trying to ask real questions that have hopefully answers for communities. We really want to try to help with things like scenario planning. If we had this happen, how can we use that as an opportunity to learn for others? And we'll continue to try to find resources to advocate for solution-oriented science. That's what we do at ESF. So we'll keep working on that, and we'll keep hoping that we're going to have wonderful students. We're so lucky to have so many of them that come up. They want to do science, but actually a lot of what we end up doing is training how to be of service to the community as well. So bringing their science back to whatever community they might be from, or taking it to urban centers, right? So connecting the dots between a remote research station in the Adirondacks and places that might be more developed, and how those things might have some useful similarities. So we're excited about having these students come up because they get to come out with us, the scientists. They get to come and experience and learn some of these things hands-on. And it's really fun for them because they get to come stay at the field station and see what it's like to be a scientist, maybe just for a day, but it's an opportunity for them to try something like this. And we fortunately have a year-round Adirondack Interpretive Center that would welcome you all to come to. It has some wonderful exhibits to bring people to. It's a great launching point if you're trying to explain to people, what is this place? Adirondack Park is a funny place, right? It's a state park, but it has people living in it, and there's no gate, right? And there's all these things about our part of northern New York that are kind of special and interesting. And so trying to tell that story and connect the dots between the natural science and the social piece. What do we as humans do? How do we engage and interact with our landscape? What do we care about? So I'm happy to take a question if there's any time, and I appreciate your time today. Oh, and I did want to mention, if anybody's interested, I'm happy to talk to, and we had a wonderful artist in residence make a graphic novel about some of what I just told you. So, you know, not everybody loves graphs, I know that. If you want to come and see this, come see me when we have a break, and I'm happy to share this comic. It's really a fun way to learn about science, and a little bit different than this. So thank you.